So let's start by writing a simple class to illustrate how the class works in Java. We will use an example of rectangle object. Now, a rectangle object apparently has two fields, length and width, right? So that's how we are going to define a class of rectangle. We should have a double length and a double width as its attributes. Now we've been also noticed there's something called private. A private is an access specifier. An access specifier is a Java keyword that indicates how a field can be accessed or a method. So we already see public static void main. In this main method definition, we have the public keyword instead of private. The public access specifier means the field or method can be accessed by code inside the class or outside the class. So in our class, which is definitely different from rectangle, we can still call the public method. Whereas the private method or field will only be accessible by methods inside the class, method of the same class. So this is how we achieve encapsulation, because the data inside these two variables are private. Anything outside rectangle may not be working, may not access these two. So you have to use method of that rectangle class to access these two attributes, which achieves the encapsulation we talked about. The rectangle class thus will have the set method for length and width. Apparently, because length and width are private, you will need to use a method to set it. Otherwise, they will be inaccessible. And once set, when you want to read the value of these two attributes, you will need a get method to get the value of these two attributes. And finally, you will have a get area method. So let's see an example of set length. Set length start with public. Apparently, this has to be public, because otherwise, if this is also a private, then both the set length method and the length method attributes are private. Nobody else from outside the class will be able to set the value. And this is void because this is simply setting the value, and we will pass in one value into the set length method so that this length, the attribute length, will be equal to this length. And this is the definition of the set length method, where we just simply set the class attribute length equals to length. And all this code actually comes from the length demo and the rectangle Java sample code. So once we start creating a rectangle box, we are going to use a new keyword to create a rectangle object. At the very beginning of object creation, we will have length and width in the object. However, when it started, it only has a default value, which is 0 for double. Once you call the set length method and set this to 10, the rectangle's length attribute will become 10. This is the state of the box object after the set length method execution. States means what value are held currently in this object. Then we can use the getLength method, which returns the class attribute length to provide outside world the length of this rectangle. Similarly, the set width and the get width method can be created. All this you can find from the length width demo and the rectangle Java sample code. We'll also have a get area method, which will simply return length multiplied by width, which is the area of this rectangle. Now, back to all these 5 methods, you can clearly see that these class methods can be divided into 3 blocks. The first is set. You are setting every attribute, 1 attribute per set method. Similarly, you have a get method, 1 get method per attribute. And finally, we have this get area method, which is the logic applied to this specific class. So basically, there are 3 types of methods. One is set, one is get, and another is whatever logic is specific to that class. For a rectangle, it's get area. For a bank account, it may be calculating performance or something like that. So because of the concept of data hiding, fields in a class are private, as we already see. The method that retrieves the data are called accessors. And the methods that modify the data or initially set the data are called mutators. Each field should have an accessor. Each field that the program wishes to be viewed by others needs an accessor. Each field that needs to be modified needs a mutator. Mutator apparently is a set method, and the accessor is the get method. So set, these 2 are accessor, and get, these are mutators. Because of this set and get convention, other name for this method are getters and setters. So usually in Java convention, you will create those methods, calling them set attribute name or get attribute name. You can have something else, like instead of set, you can put like a make length. But usually people will just use set and call it setters. Similarly, get for getters. Data hiding, an object hides its internal private fields from code that is outside the class that the object is an instance of. Only the class method may directly access and make change to the object's internal data, and code outside the class must use the public methods to operate on the private fields. And that's basically what we are talking about in this session. You may wonder why this is going to happen, especially for simple things like length and width. What's the difference between directly accessing those fields instead of using the methods? You have to create 4 methods instead, right? Data hiding is important because classes are typically used as components in large software systems, which involves a team of programmers. Again, we come to the question of a team, your teammates. Data hiding enforces the integrity of an object's internal data. It provides only 1 entry point for your data. Only 1 entry point ensures if there's logic behind your setter and getter, there will not be any confusion and no accidental change. Your change code is not like spread outside everywhere. It's written in the same place that when you want to make modifications, you make it in 1 place. So your legacy code will not be affected. And sometimes some data is a result of a calculation, like the area is length multiplied by width. It would be impractical to use an area variable here. Why? Because data that requires calculation has a potential to become stale. Once I change the length, the area variable that you already created may be out of date. Either you have to refresh area variable, or you are better off directly returning the calculation result instead of storing somewhere. To avoid stale data, it's best to calculate the value of data within the method rather than store it in a variable. Rather than use an area variable, it's better to use the method. And this is true both inside the rectangle class and outside the rectangle class. In the rectangle class, we are not defining an area attribute because it's not worth it. you can directly calculate from length multiplied by width. Outside of a rectangle class, you don't want to store the area anywhere. Instead, you just want to call the getArea method. The getArea method will dynamically calculate the value of rectangle's area. Doesn't matter how much you change your length and width. If you create an area on your own, area variable on your own, you have to check the length and width, the change of length and width. If your teammate change length and width in other functions, in other methods, in other classes, then you will need to update your area. So you're better off just calling this getArea. Now, any change to the length or width variable will not leave the area of rectangle still.